again. Again, this is a mini series pulled out of a longer seminar. I try to bring in some practical stuff into every session at the same time. This goes over quite a breadth of topics at a little bit of a superficial level sometimes. So there are the lecture slides for you to follow up, and I'm also going to stick around for some further discussion if there are questions. If something's completely unclear, do feel free to interrupt me, step up to the podium, ask a question, or send me a private message if you prefer that, and I can see if I can answer that question on the go. We will have some time for interaction and discussion in the second part. So happy to have you back. Last time we discussed quite a bit about explainability and trust, and also talked about human data interaction and the relevance of data, in particular, as it often is one of the underlying causes for biases or other issues with the models. And yeah, we had this interesting example around SHAP values that you interacted with. And I learned that churn is not a word that is very common and familiar with everyone. So that exercise is already improved for the next generation to come. But in this session, I thought it might be fun just break out, be a little bit more speculative about some things, and sort of look at a little bit more of the unusual models and beyond. So I want to talk about mental models, embodied interaction, how that plays into human AI interaction and human AI interaction in futures. So depending on if you've been in at IK, or maybe if you have a background in cognitive science, for example, then the whole consideration that humans are deeply embodied and social creatures is nothing new whatsoever. But I just want to cover some basic ideas. So the basic concept of human embodiment is, of course, it can be seen as a theory of interaction. It is also a theory of cognition, which is all about sort of presence and practice, about how making sense of the world is about us being there uh, with our bodies in a physical reality. So it sort of goes away from Cartesian dualism that sort of sees the mind as this sort of separate, pristine thing, to seeing a brain as a wet, messy thing embedded in a human body that it goes through very complex contexts and has other complex human beings and other beings in there. And it adds a whole sort of emphasis on understanding processes very much through this sort of pre-ontological embedding. There's, of course, a very close relation there to phenomenology as the study of experience and perception. But I don't want to get onto too much of a tangent about this. Just to point out, if you're interested in how embodiment is relevant to how we think about interacting with computing, there's this fundamental work making this transfer case. It's called Where the Action Is, Foundations of Embodied Interaction by Paul Durisch. It's quite the stock in HCI. And it's just a really, it makes a lot of very compelling cases arguing around how interaction design is best understood by really considering technology use in context. There are aspects related to that. So aspects around cognition that are related to our embodiment, such as the concept of mirror neurons, or a theory of mind, which allow us to sort of simulate and understand a little bit about the actions of others, that are really important to keep in mind when we move towards thinking about this concept of AI and ML systems, often appearing these days less as tools, or less purely as tools, and more also as agents with some sort of agency then, right? So this is important. It's a way of extending here a tradition in interaction design, which is about cognitive dimensions. The most famous example is affordances, right? Where there's the long established theory of affordances that has a big tradition in design, where the shape of objects already suggests how we might deal with them, and it's important to make an argument here. I think that with systems becoming more agent-like and having these unpredictable outputs and everything that we discussed in the prior sessions, some AI and ML systems are, of course, presented very much like tools, and that's a different story. But we're seeing now all sorts of agent and support systems, conversational interfaces, and these are the ones I want to highlight a little bit in this session. And with these types of systems, I just want to make the argument that there are other cognitive dimensions that are now becoming much more relevant, that were less relevant when we were talking about direct manipulation as an interaction paradigm, right? So these things, like theory of mind, for example, become important. Um, Not in the first instance. That's a whole other discussion around an AI having theory of mind. I don't mean that. Um, what I mean mostly is that when we interact with systems that appear as agents to us, then we have this tendency of projecting a theory of mind into these agents. That's just a human tendency. And yeah, you see that in this fun old clip from Star Trek. Okay, it doesn't seem to want to play, but some of you may know it. It's from one of the early Star Trek movies, and there's an interaction of these people from the future with a traditional sort of maybe early 90s computer, and the person tries to speak with it, and the computer just doesn't properly react. And then a person gets a mouse, and he's like, "Okay, hello, computer," and it still doesn't work. Anyway, this is sort of picking up on these notions of projecting capabilities into the systems that they don't necessarily have, and at the same time thinking about cognitive dimensions in a way that it can inform human AI interaction design decisions. So I think this is a really interesting concept. It's a developing area that I now cover. So that's what I meant with it's a little bit more speculative this time around. Right, but it is really relevant to yeah, to thinking about systems, in particular the ones that appear a little bit more agent-like. Now, actually speaking at IK about these systems and proposing that this is a recent development is a little bit of a heresy because particular at IK has a long tradition also of some people, for example, Professor Ibke Wachsmuth, they're working on embodied conversational agents. So there were waves of development in these agent-like systems. I think there's now arguably been a little bit of that iPhone moment with Siri and Cortana and all Google Assistant and all these systems really being in everybody's pockets and being more omnipresent. Um, so that these considerations just have a new relevance, right? But it's to say there's a long tradition actually to look back to, and there's a sort of high level overview thing. So many interesting links for you to follow up in the slides there again in the shared space if you want to download them. One of the key concepts that always gets discussed in this um, context is the uncanny valley, of course. So this whole idea that yeah, the more you increase human likeness, in principle, familiarity goes up. But then there's this sort of zombie-like stage where yeah, human likeness is almost realistic, but not quite. And then this is sort of very scary to us, zombie-like, dead-like. And this is one of the important and key considerations when we think about systems that appear as agents. And arguably, this can not only be the case with visual appearance of a body, but for example, also in voice-based interfaces, when you have voice synthesis and get very close to it, but not quite, it can leave a certain eeriness. So that's how this concept is really important. And this carries on through then into communication. And it's really important to consider how we communicate with one another and how much noise is in there and how much we compensate for yeah, for lack of completeness in how we form human expressions and how much noise there can happen in between. how much we compensate there with simulation. And that's also a really interesting aspect, again, from both points of view. If you want to build AI systems that do this well, there's a lot there to consider in terms of giving it world models and so on. But on the other end of the spectrum, there also, we typically project these capabilities intuitively into systems if they leave the impression of being able to communicate. And that's a big issue if these expectations are then not met. So yeah, this is a big challenge in natural language interaction. A lot of ambiguities that are difficult to deal with. Um, yeah, I think I want to not get more into this, but instead get to the next point, which is one that was already expressed in what I just said, but not explicitly. So this whole concept of projecting human-like capabilities into systems that have some sort of agent-like appearance is called anthropomorphologization. And it's this whole concept that yeah, we tend to do that with all sorts of things that are not humans, right? Just give a car some eyes, and we already start talking about it like a person sometimes. Or you hear utterances like the computer did not like me today, as if that was something a computer would be thinking. Or it decided to crash, or yeah, I feel betrayed by my word editor. All these things really speak volumes to how we project human-like capabilities in and yeah, understandings into these systems, uh, which just lays the perfect groundwork for a lot of misunderstandings. So when you then think about how to do design for interacting with AI and ML systems, it's just really good to be aware that this will happen. And it's really good to involve people in the testing to see, okay, to which degree does it happen? Where do these misunderstandings come from? And it's ultimately one of those things you can only really learn about in practice. And then you want to avoid catastrophes like this one. This is taken up by interaction design frameworks as well. Yeah, there's often a talk about natural user interfaces, for example, um, as we see multimodal interaction expand. I really like this framework. It's a reality-based interaction, and it's really sort of just saying, okay, we have these innate models of naive physics that we built up through our lives. We have a certain body awareness and skills. We have a certain environmental awareness and skills, and we have social awareness and skills. And we project that into our interactions, whether that is with other humans or with systems that have some indication of autonomy or human likeness. So again, this is something to read up. But when we are around other human beings or other, those agents that we know most innately, that we have arguably some evolutionary development that prepared us to interact well with them, one of the most exciting things we do as humans is, of course, to collaborate, right? And it's at the core of why humans are social beings, because there's a lot to be gained from collaboration, forming shared intentions, executing joint action. This is important even to traditional interaction to design, to the point that there's a dedicated famous conference series called Computer Supported Collaborative Work, for example. And there are key concepts at play here that we already touched upon, where you can now sense that with AI and ML systems, there might be some tricky challenges here. So trust, reliability, and responsibility come to mind. So yeah, we apply the principles that we know from human to human collaboration in human to non-human collaboration. There's a long history, for example, in human to dog collaboration to allude to. But we are now seeing this sort of play out with more and more autonomous systems, with systems that have more ability to act in complex contexts and to learn and pick up complex patterns of behavior. So there's this famous example again with a video for you to look at later if you want to of Baxter the robot, which you can at least show it sort of certain manual executions of manual labor tasks, and it can then learn to repeat them, even though sometimes an object might be displaced a little bit. And what we're seeing there is really a movement from interaction with computer systems like in direct manipulation to coordinated action to something like collaboration. Uh, this is really important to look at as, again, one of those developments, as often in technology, where it can take a positive or a negative twist. So there are arguably dark patterns around collaboration. So yeah, there was this time, I'm not sure if they still do it, where Facebook liked to ask you to tag other people in pictures in a pseudo collaborative framing, which was, of course, yeah, arguably helping it to build up databases for other questionable purposes. And yeah, so it's just really to be aware that these patterns, because we tend to be positive about collaboration, they can also be abused, but they can have really nice examples and outcomes as well. So if you think about human AI interaction in recent years, amazing creative tools are starting to appear, right? For example, in the style transfer space, we now have all these neural networks that can be trained to learn particular art styles, for example, or even to generate new artistic expressions or pseudo artistic expressions from the ground up or based on verbal input, for example. And these can arguably be really productive, yeah, proto collaborative tools where we use outputs of such networks as an inspiration or as a sort of an artistic back and forth. And of course, yeah, there come, yeah, for reasons of time, I won't get into details, but there are a couple of points you could make here about which machine learning techniques are most relevant here. So convolutional neural nets and general adversarial networks play an important role, of course, in this space. But yeah, even in the first session, I think some of you looked at this fun example of an application of general adversarial networks here for image generation. And that seemed maybe very playful and maybe very messy. So some outputs were good, but others were questionable quality. But of course, we see this space develop rapidly, and there are these crazy examples like a gun, a generated painting auctioning off for more than $400,000. So that just goes to say this is not just uh, a pure experimental space any longer. Right. So that's exciting. You can also make a little bit more provocative arguments, go further, maybe. One of the sort of repeated lecturers and well-established professors who every now and then pop up at IK is Luc Steels, who does the evolutionary linguistics, and and his whole point of his work is to use AI systems to simulate the emergence of language. And actually, one of the key motivations he often cites is not just to be able to do that, to have, I don't know, pairs of robots who come up with a language system, which is fun to do, of course. But it's actually also a very interesting take on forming scientific theory or delivering scientific proof. Because one of his arguments is if you can make it emerge in a system where you at least understand how it's laid out, then you can form an understanding of how it may have come about also in nature. So that's a really interesting argument, and yeah, really a sort of a little bit more far-fetched thought around human AI co-creation in a research application in a way. Right. I mentioned earlier that, of course, this whole concept of having a world model to be able to predict likely actions of the other can also be seen from the AI or the agent point of view. And this is just um, saying that in other words. Um, and it's really important. And it's yeah, I think I want to sort of do an in between wrap up and get into the interaction soon ish today. So this was a little bit of a part of the session that relates to the final bit actually of the pair guidebook on human AI interaction, which we now somehow managed to cover all in this four lecture series. So we talked today a little bit about how human cognition and approaches to interaction are shaped by our embodiment. And yeah, actually with this, we are less flexible than we might be inclined to think. So we often apply quite firm models that can lead to misunderstandings. Um, yeah, design applies insights about cognitive dimensions, and there are arguably now new cognitive dimensions to consider when we interact with agent-like systems. Um, and yeah, human AI collaboration can be very valuable, but we need to plan with insights about human-human collaboration and the patterns we apply, because it's very likely that people will assume that similar patterns are possible and try to go with them. And as always, such insights can also be exploited. So that what I meant is, yeah, if you ever find the time or are interested, this is a really helpful practical guidebook that goes into a lot more detail in many ways around these various areas which we've now touched upon through this four lecture series. Right. And I talked about agent-like systems. There's of course the physical reality to them in robots as well. And while this often still seems like an abstract future, it's really not. I mean, we have so many robots in practical everyday use. Yes, they are usually not very smart yet, but still these interaction design considerations are starting to apply. And yeah, we see a big sort of silly dull agents already making it into consumer markets for many years now. So anyway, this is just to say this is really, really relevant. It sounds abstract, and in many ways, the interaction design concepts around these technologies are still developing. But there's a certain sense of urgency, really, to catch up with the technology developing. Right. Yeah. So you can sort of make the point that agents and robot systems are now sort of they've gone through the stage of being a curiosity or a novelty to seeing these pseudo pet uses to being sort of guidable workers. And there's a lot of movement now towards more flexible sort of collaborators in the way the systems are framed, at least in the research world. And of course, you can then ask the question if we already had the iPhone moment of software agents, which robot will be the iPhone of robotics? What does it take? Yeah, which application area might that be? Which capabilities are required? Which interaction modalities will it have? Um, that's an interesting discussion point, but I want to get to the interaction I had planned. So I will leave you with that as a philosophical thought or maybe for discussion later today. I want to get into one more interaction session and leave enough time to do this and then also discuss. And this will be, in the first session, if you were there, we interacted with a lot of different AI systems and really just started thinking about who are these made for, who are the target users, who is the target audience, what does that then mean in terms of how we present the system and its capabilities, how much flexibility there is, how much control is given to the user, or how much yeah automation is in the system. And I now want to do a similar thing, but focus particularly on agents, And I want to suggest that it might be really, really interesting to start thinking about when you interact with these systems. It's probably some fun anyway, but I really want to encourage you to think about again how the interaction with the system feels in terms of how you interact with, because these are now conversational interfaces. So what sense of an agency do you develop when you interact with that system, about that system? And also, how is it framed? And what does that mean? And where does this take us in terms of our understanding of what a computing system is? Right. So from interacting with these systems, you can really start asking interesting questions, whether it is now the time that we should start thinking not only about human AI interaction, but also about human AI relationships. And that may sound a little bit silly, but I think there is an earnest angle to this. So we're sort of really missing the medium to long-term perspectives and understandings about what does it mean to people to be interacting with these systems. For example, replica. Do people really start building relationships to some degree, be they abusive or not, with these systems? It's really an interesting and important angle where we need to borrow methodology from sociology, for example. In particular, again, not from the angle of necessarily assuming that an AI system would, from its perspective, form a relationship. That's a whole different debate. But we certainly, by projecting these abilities into these systems, do that. And that is, we understand some fundamentals, but we don't understand how it shapes our interactions with these systems over time, and how relationship like they really are. So I would posit this is a really interesting research perspective developing right now. It also relates to interesting technology trends, such as federated learning, if you want to treat this seriously and in a, for example, privacy and data security aware way. But yeah, there's some examples of fun research and investigation into this. So you may have heard of the sort of robot journeys experiments. So, for example, Hitchbot, a robot that can do nothing but just has a goal sort of printed on it where it wants to go, and then the experiment was to see whether people take it to its goal just by the nature of its agency. And this gained international attention for successfully hitchhiking across Canada, Germany, and the Netherlands. But it also gained attention for being dumped in a ditch in Philadelphia or Pennsylvania somewhere. So there's this abuse factor showing through again. So essentially, it made it across the entire world only to then be murdered. And isn't that the full subject of a human-like experience? I don't know, but it's a really interesting space. But these properties are also now actually being commercially exploited. So you see these delivery robots pop up here and there, and these companies are starting to use that pattern if they get stuck somewhere, for example, to reach out to passersby to help the robots get unstuck. Yeah. Anyway, that's just to say these patterns, are not just sort of fantasy playtime. I think in a general sense, if we want to link back to the history and development of HCI, maybe as a sort of a final point, we had akin to the sort of the springs and winters of AI. There's a history of HCI that I didn't really explain, but it started out as human factors, very much inspired by psychology, workplace psychology, where humans were seen as processors with operating characteristics. And then it developed into a focus on usability and a little bit more complex interaction with personal computers in particular, where people were suddenly seen as agents with projects that need to be effective and efficient, and that was highlighted. And then we had the third wave of HCI, focusing on the user experience aspects of social interaction with the emergence of the internet and social media, where people and individuals were seen as socially, materially embedded interactions. And I think with these systems now developing to being more unpredictable in their outputs, more chaotic, breaking with these traditional interaction paradigms that were developed in history along this development, and in particular, the usability and user experience wave. With the systems now changing and how they behave and appear, I think it's really there's a new sort of era forming where we start to think much more about this earlier concept I introduced in session one about intelligence augmentation and interacting with agent entities, where the topics of research and sort of developing guidelines and so on is quite a bit about collaboration, augmentation, integration, where people might be seen as inhabitants of complex social digital ecosystems, where there are these agent inhabitants, right? And that's really, really exciting because it takes quite some rethinking. So yeah, I just wanted to share that. The most important point is, as always, human-centeredness, right? When we want to get these systems right and make sure that they do no harm, we just need to be open and honest and involve people at all stages of the development, in all honesty, and not overlook them here and there because it's easier, because it's more efficient, because we care more about the model development. It's okay to some degree for some people to do, but there also need to be the checkers, those who make sure that the interaction patterns, by and large, go into a positive direction. Goes hand in hand with avoiding AI solutionism, where we do it just because we can, to really go for ideating in AI in a way where we really ask, what is the service need? What is the purpose a system is to do for humans? And then is this really something we have to use AI for, or can we use another system? And then we need to start thinking about, okay, when humans approach this problem or task, which mental models will they apply, and which mental models will they apply if we offer them, a more traditional ML and AI system with unpredictable outputs, but that's still a little bit more tool-like, and which models will they apply, and how will that work in the whole contextualized situation if we give them a system that is more agent-like as an alternative. And these things really need to be thought through. And if we do that well, then there are amazing opportunities. Just pointing out some examples here from accessibility, that is really seeing great advances with machine learning in it. And it's an active area of research, so just a bunch more research sources if you like to read. And since we're running out of time, this is just to emphasize again, I picked out the Google framework to scaffold this mini lecture series along the longer one. Actually, I developed somehow aligned it along the Microsoft framework, which has similar guidelines. It looks like this. And yeah, we discussed the pair sort of Google's version of the People AI guidebook. And here are just, it's in the slides. These are just the sub points of the 6 cards of the higher level framework that I referred to quite a bit, and we covered some of the fundamentals. So that's just to say where that all sort of falls into place. And yeah, of course, the question ultimately remains, how far should we really take this, and what does it do to us? And I thank you for engaging in a little bit of a debate about that with me today. So yeah, it's really interesting. I think we'll keep asking the same questions from the HCI tradition now in this space. So how do we make it so that systems really work well for people? And also, what does it do to people to be living and working with these systems? And that requires entirely new angles when we talk about machine learning and AI. I think that's maybe the core message. So thanks for joining. And if you have any further questions or you want to discuss, I'm just going to step off the podium. And, yeah, we can have a gather town discussion if there's anything you still want to share or talk about. So bye for now.